a heartbeat, a voltage, a stock price, a sound wave. Engineering calls all of them the same thing: signals. Functions that carry information through time. They look infinitely varied. But here is the claim this episode will prove: every one of them is built from a tiny alphabet of elementary signals, and there are exactly two ways to spell them out. Let's meet the alphabet. Letter 1, the unit step, U of t, 0 for all negative time, 1 for all positive time. It is the mathematical model of a switch turning on. Integrate the step, and you get letter 2, the ramp. It climbs at slope 1, starting from 0. Step and ramp are a calculus pair: integrate one way, differentiate the other. But the most important letter comes from asking a dangerous question: what is the derivative of the step? 0 everywhere except at the jump, where the slope is infinite. So we build it as a limit. Take a rectangular pulse of area 1. Squeeze its width toward 0, and its height must grow toward infinity, but the area stays locked at 1. In the limit, we get the impulse, delta of t, infinitely narrow, infinitely tall, area exactly 1, which is why we draw it as an arrow, labeled by its area, not its height. The impulse is not really a function. It is an instruction: concentrate a unit of stuff at a single instant. And it has one superpower, the sifting property. Multiply any signal by a shifted impulse and integrate, and out pops the signal's value at that instant. The impulse samples. Remember this, it is the seed of convolution. Next episode. Letter 1, every complicated signal expression is built from just 3 moves applied to a basic shape. Here is our test signal, a triangle centered at t equals 1. Move 1, the shift. Replace t with t minus 2, and the whole shape slides right by 2. Minus means right, the signal happens later. This backwards feel trips everyone up once, internalize it now. Move 2, the timescale. Replace t with 2t, and the signal squeezes toward the origin by a factor of 2. A number bigger than 1 compresses. Again, backwards from intuition, and again, that's the exam trap. Move 3, the flip. Replace t with minus t, and the signal mirrors about the vertical axis, time runs backwards. Shift, scale, flip. 3 moves. Every expression you will ever see, including the monsters on gate papers, is a sequence of these 3. Every complicated one more piece of vocabulary before the roadmap. Square a signal and integrate over all time, that is its energy. If instead you average the square over an ever-growing window, that is its power. The classification rule: a pulse that dies out has finite energy and 0 average power, an energy signal. A sinusoid that goes on forever has infinite energy but a finite average power, a power signal. A signal is one, or the other, or neither. Never both. This distinction decides which transform applies later, so it is not just bookkeeping. One more piece of now the promise from the cold open. Take any signal, this arbitrary wiggle will do. There are exactly 2 ways to spell it in our alphabet. Road 1, slice it into impulses. Every instant of the signal is a tiny scaled, shifted delta, the sifting property, run in reverse. Follow this road and you arrive at convolution. Road 2, build it from spinning exponentials, the e to the j omega t arrows from episode 1, each with its own speed and size. Follow this road and you arrive at Fourier, and beyond it, Laplace. The entire subject of signals and systems is these 2 roads and the bridges between them. That is the map. Keep it on the wall for the next 10 episodes. Now the promise, a classic exam question. X of t is a triangle from 0 to 2, peaking at 1. Sketch x of 2t minus 3. Don't guess the order of shift and scale, that is exactly where the trap lives. Use the bulletproof method instead, the argument method. The original signal lives where its argument is between 0 and 2. So set 0 less than 2t minus 3 less than 2. Solve for t, the new signal lives between 1.5 and 2.5. Width 1, compressed by the factor 2. The peak sits where 2t minus 3 equals 1, at t equals 2. Draw it, same unit height, the amplitude never changes under time operations, half the width, centered at 2. No memorized order of operations. The argument method never lies. Classification, it is a finite pulse, so finite energy 1/3, if you carry out the integral, and 0 average power. An energy signal. That completes the alphabet, the 3 moves, and the 2 roads. The number to remember, 1. The area under the impulse. Every sample, every convolution, every transform in this series ultimately rests on that unit of area at a single instant. Next episode, what makes a system LTI and why those 2 letters change everything.